Okay, we're going to look at two other types of nuclear reactions. One is electron capture, and the other one's going to be bombardment. So electron capture, it's a continuation of the same thing. So I'll just say that to begin with. So we just take 19 minus 1, we get 18. We do 40 minus 0 and 40. And then, yes, that's over here, that's argon. And so we just got a reaction, we got an answer. So the tricky thing, of course, is that this is not exactly the same kind of thing as the decays that we were showing up at the top, because we are not giving off a beta particle or whatever. We are actually consuming. So this is also not the same thing as an atom getting a negative electron and becoming negative. It's not that either. It's not something becoming ionic. So what basically is happening is that if you've got potassium, and notice that potassium has like 19 neutrons, protons. If you have an inner electron and it just happens to get too close to the nucleus, and this nucleus is going to have to already be like a little unstable anyways for this to happen. You know, there's electrons all around it, right? Lots and lots of electrons everywhere. So one of the inner electrons in that atom itself is absorbed into the nucleus. And when it does that, it combines with a proton, and then it emits just basically a big old shot of energy. It's a neutrino. You don't have to know what's emitted. In this particular situation, a neutrino is emitted, and it has a lot of energy, and it flies away. But what you need to know for electron capture is just right here. This is what we want you to be able to do, is just to recognize that it's an electron. Notice that it's its own electron, though, so I know that's weird. But it's its own electron that it's been absorbed to the nucleus. And when it does that, it has a reaction, which basically changes the element. Crazy stuff going on, some crazy stuff. So that's electron capture. Okay, so then the other thing is more common, and it's kind of like, in a way, man-made starting. Not on the sun, but there are places where, like on the sun, where you have these reactions that it's bombardment all the time, and crazy stuff goes on. But here on Earth, we have a lot of cool science stuff out there, and one of the things is we have spallation neutron sources, SNS. There's one over at Oak Ridge National Labs. There's one in Los Alamos. There's one up north. They've got them all throughout the country. And basically what they do is they take neutrons. It's not like they have them in a jar. They actually have to do a reaction to cause neutrons to go off. And it's a nuclear reaction. And once they've got the neutrons flying off of something else, they can kind of like shoot them down a tunnel, and there'll be a big sample at the end. And the sample, it's like throwing a baseball at a sample. So depending on the speed that you throw it at, you can either throw it at a speed where it's absorbed into it because it has enough energy to do that binding. And it's basically like you make these other isotopes. So like that one, we're still talking about sulfur. So that can happen. Or if you throw it at something really big, then you also can end up splitting it. So like, I don't know, I'm making this one up because I just want to kind of show an example of it. Let's say we throw it at lead 208. And lead is 82. So if you throw it at something like that and you throw it so hard, what it can do is it can cause an atom to split. And it has a same kind of a splitting pattern, basically based on magic numbers too. You can't predict the splitting pattern, so you'd have to be told that one of the elements is, maybe iron, 5626. So 5626 iron. And then in these, we'll be like, okay, so what's the other particle that came off of it? So it's the same kind of math. You do the 82 minus the 26, 12, 7. So that gives you that the bottom number is 56. And then the top number is 208 minus 56 gives us 142. And then we look up that element, 56. It is right here, and so that's barium. Again, I'm not saying that this reaction actually happens, but this is something that can happen and that we can make happen when we have neutrons and we throw them at things. So that is called bombardment, and that's another kind of reaction. I want to note one more thing. Some reactions will produce this particle, and it kind of appears to be a decay kind of a pattern, but like up here, the decays where they are products. Sorry. So it can produce, you can also produce a neutron, but that's about to go into something else that we'll look at, and it has to do with how nuclear reactors work. So just because you see a neutron, it doesn't necessarily mean it's bombardment. Basically, if you see some particle other than an electron, because electrons aren't, we don't throw electrons at things, but any particle, you could throw a helium at something. You can even throw like an iron at something. You can, if you get enough speed. And so bombardments are just basically when you're throwing particles or elements at other elements, and they either merge or they split something.